Hello, this is Ms. DB, and in this lesson we're going to review how to do Chapter 11, Section 5 on angle relationships in circles. So we will find the measures of angles formed by lines that intersect circles and then use those angle measures to solve problems. In the last lesson we looked at the angle of an intercepted or an inscribed angle, and this is going to be similar, but we're going to look at what happens if the angles are at different places in the circle. Our first one is a tangent, and remember a tangent line will touch a circle at just one point. If a tangent in a secant or a chord, so it's going to go through or have endpoints on the circle, intersect on a circle at the point of tangency. So right here is our point of tangency, and the two lines are coming together right there. Then the measure of the angle formed is half the measure of the intercepted arc. This is exactly the same as an inscribed angle because really this is an inscribed angle. It's just that one of the lines is a tangent. So again, this angle will be half of the measure of its arc. So if this arc is 80 degrees, then the angle is 40 degrees. This is the same as for an inscribed angle. Same formula. It's just that instead of having two chords, it's a secant or chord and a tangent line. Here's an example where you'll be using that. Notice that HFG, that angle is an inscribed angle, which we talked about yesterday or in yesterday's lesson. In this one, we're going to, here's a tangent and a chord, and over here G is also a tangent intercepting a chord. Intersecting. So it says to find measure of angle EFH. Here's E, here's F, here's H. We're talking about this angle right here. And the great thing is that we know its intercepted arc is 130 degrees. So that means that angle EFH is going to be half of 130, which is 65. For the second part, using the same figure, now we're looking for the measure of arc. Remember, this is arc. GF. Okay, GF. Here's arc GF. It's that part of the circle right there. And we're looking for its measure. And if we know it's an angle, oh, here we go. I couldn't find the angle for a second. Here's the angle down here. We know that this chord, FG, and this tangent line are intersecting right here. Now we aren't given its angle, but we are given that the angle on the other side of that FG chord is 122. And together 122 plus whatever this is will equal 180 because they are a linear pair. They're supplementary. Together they form a straight line. Therefore you can find that angle by taking 180 minus 122, and then you'll find the measure of angle G, which is 58. So you find that, and then you can proceed with the theorem, which says that that angle 58 will be half of the measure of its intercepted arc. But then wait a minute, what is its arc? We don't know because we have here no measurement. So in order to find that measurement, let's see what else we know. We know that FH is 130. Let's see, what else do we know? We know that, let me get a different color. I'm going to use red here. We know that this angle is 122. On this side is 122, which means that its arc, its intercepted arc, would be twice that. And 2 times 122 would be 244. So 244 would be all the way from here, all the way to here. All of the circle is red, is part of that 244, except for what I had already said I was looking for the measure of the arc. This turquoise part is not included in that 244. So if I take 360 minus 244, that will be the measure of the arc that I'm looking for. 6, 1, So 116. So I found that by subtracting from what I knew. I could have also taken my angle of 58 and used the theorem. 58 times 2 is 116. So there is more than one way to solve these problems. I just did maybe the long way, but you could have also used the theorem and doubled 58 to get to 116. You can do more than one way to double check yourself. All right, angle STU. Angle S, and then to T, and then to U. So we're talking about this angle right here. We know that its intercepted arc is 166. Here's its intercepted arc from here to here is 166. So all we need to do is take half of that, and we'll get 83. Okay, same diagram. This time we want to find the measure of arc SR, which is from here to here, and its angle is 71. So we can multiply by 2 and get 142. All right, next we're going to look at what happens if you have two chords or secants intersecting inside the circle, in the interior of the circle. This is different. This is not the same as inscribed angles or angles that have its vertex on the circle. The measure of each angle formed is half the sum of the measures of its intercepted arc. By the way, if you did the journal this week, the investigation in Sketchpad, you discovered this by looking at the measures of these angles in Sketchpad. If you haven't done that, you should go back and do that, because you'll discover this theorem and the other ones that we're doing in this section as well. So what do we need to do? We need to add together the arc that this angle is holding on to, and we also need to add to that the angle, or the arc that this angle is holding on to. So measure of angle 1 will be the sum of these two added together, and then take half of it. Let's see that in action. Measure of angle AEB. We're looking for this angle. So what we do is we take the measure of the arc that it intercepts, 139, plus, see this one here, intercepts angle arc DC. We add these two together, and then we take half of that. So we take half of 252 and get 126, I believe. And that's the measure of angle AEB. It would also be the measure of angle DEC because they're vertical angles. So both of them would be 126. Sometimes, I'll give you a little heads up, sometimes you have to find that angle before you can find the angle they ask for, which might be AED. And you could do that because these two angles together are a linear pair, they're 180. So then you just take 180 minus 126 to find this angle. And you are going to have to do that once in a while. Okay, this one asks to find measure of angle ABD, this angle. And we can do that because we know that we would add 65 plus 37 together and then take half. So half of 102 is 51 degrees. So this angle measure is 51 degrees. And then again, if you needed to find angle ABE, you would take 180 minus 51, which in this case would be 129 degrees. And this would be 129 because it's vertical angles, and this would be 51 degrees because they're vertical angles. So you can find all of those measures if you find one. And again, R and M, here's an example where we don't know its intercepted arc, or the one on the other side. But you can find this angle because you can take the measure of angle M and Q will be equal to 91 plus 225, and then you can divide that by 2. So that is 158 158, which means this is 158. And then we can use a linear pair or supplementary and subtract from 180 to get that the measure of angle RNM is 22 degrees. All right, here's another theorem. This is if you have angles formed by lines intersecting outside of the circle, exterior of the circle. So if there's 3 times where that could happen. It could be a tangent plus a secant, and that would be case 1 here. It can be 2 tangents, which would be case 2, or it could be 2 secants, which is case 3. All of these have the same formula, and it is that you take the arcs and you subtract them and take half. And so instead of adding. So here's one of the intercepted arcs, arc AD. If you know that one's measure, and the measure of the other arc is right here, so they're touching each other in this case, then you would subtract them and then take half of that. Take the larger one minus the smaller one. In the case of 2 tangents, you really have the whole circle covered here. This arc, this great arc here, minus the intercepted arc from the inside. So you subtract those and take half of that. And then finally, if it's 2 secants, you'll have the greater arc and you'll have the smaller arc, and you'll subtract them, and then you will take half. All right, find the value of x. We're looking for this little tiny angle. It's not tiny, but there's no room to put the x there, so they're pointing to it. So we know that we are going to take this arc, 87, minus this arc, which you can barely even see, is 7, and you'll get 80 degrees, and then you'll take half of that. So you subtract them, and don't forget to take half. Here we have a tangent and a secant, but we do the same thing. You take your greater arc minus your smaller arc, 200 minus 74, and then you divide that by 2. And you'll get 63. Now sometimes you'll be looking for one of the arcs, and you'll be given the angle of that angle that is intersecting outside the angle formed outside the circle. So in this case, you would put 25 is equal to, remember what we did? We subtracted the 2 arcs and divide by 2. So your first step in solving in this case would be to multiply both sides by 2 to get rid of the dividing by 2 to undo it, or to get rid of, if you wrote it like a fraction, to undo the fraction. So we would have 50 is equal to 83 minus x, and then we'll subtract 83. And we'll get a negative number, but that's okay because it's equal to negative x, and then just multiply or divide both sides by negative 1 to get 33 degrees for x. All right, this is just a design application. It looks more complicated than it is. It says the measure of arc FH from here all the way to here is 108, and LJ arc is 12, and they want the measure of FKH. So it's just exactly what we just practiced. You would just say that that angle is 108 minus 12, and then divide by 2. Here's an example with an eyeball. It says 2 of the 6 muscles that control eye movement, are attached to the eyeball and intersect behind the eye. If measure of angle arc AEB is 225. Okay, this is an interesting one because this one shows what do you have if you have 2 tangents. We don't have enough information, do we? If this is 225, how do we subtract the smaller one? Well, because you know there's 360 all the way around a circle, we can find the smaller arc by taking 360 minus 225. And we get 135. So now we know we have 225 here and 135 here. So to find this angle, you just subtract them and divide by 2. And this is 12, so 90. And then half of that is 45. If I did my math right. Yep. So angle ACB would be 45 degrees. So sometimes you'll have to, especially in the case of two tangents, you will, remember that all around is 360 degrees. So if you take the measure of the arc you know, subtract that from 360, you'll get the measure of the other arc. This is a summary of what we learned in 11.4 and 11.5. So in 11.4, you learned that an inscribed angle is half of the measure of its intercepted arc. And in this lesson, you learned that that is also true even if one of the rays of the angle, one of the sides of the angle, is a tangent. It's still true. Half the measure of its intercepted arc. And then we also learned that if you have two chords or two secants intersecting inside the circle, that you add the arcs, and divide by 2, the intercepted arcs formed from that angle. And then also if they intersect outside the circle, then you subtract the measures of the intercepted arcs and divide by 2. So this would be a nice little summary. It's on your worksheet that you could print and keep and refer back to as needed as you work on the problems in this section and quizzes and tests. All right, that's it for today. Thank you very much and have a wonderful day. Please make sure you ask me if you have any questions.